Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on one sample proportions. We're going to do both a hypothesis test and a confidence interval. We're not going to do the conditions on this at all, but we will do the conclusions and the parameter in the exit ticket. Here, we're just going to run the test to make sure that we know how to run the test, okay, and do the calculator portion and write our formulas. So scenario, stealing Coke. Slurp Shack is a hot spot for high schoolers and college students who crave oversized burgers and bottomless fries and self-serve drink stations. The restaurant's free water cup policy is meant to be a courtesy, but the manager, Mia Carter, suspects that too many customers are stretching the rules. Studies indicate that about 18% at self-serve beverage stations take soda after asking for water. So about 18% seems like that's going to be our claim. So it seems like we have a proportion of our population proportion of 18%. Mia believes the problem is worse at Slurp Shack. In other words, they're taking more soda when they say they're getting water. To test her suspicion, she collects a random sample of 85. Hey, good thing they said random sample, because if we were doing our conditions, that'd be the first one of 85. So my sample size is 85 from the 970. So 970 would be the population if we were working with our conditions. A water cup and finds that 24 of them help themselves to soda. So 24 of that 85 took soda. All right. At a significance level of 0.03, so we have an alpha equal to 0.03. Test and managers claim that more. So in other words, our null hypothesis, our alternative hypothesis will be a greater than because it's more than 18%. So we're looking more than 18%. So we've already said we're doing a hypothesis test. Our formula is simply the sample proportion, which we don't have, minus the population proportion, which in our case was 18%. And then it's divided by the square root of the population proportion, 1 minus the population proportion, and over the sample size. So we've already filled in a lot of information. We've already collected a lot. And so we can go ahead and start writing that down and making note of it. So we already know that 24 people are taking Coke when they're not, or soda when they're not, out of the 85 who asked for a water cup. This is from the random sample. P hat, they didn't explicitly give us P hat. We had to calculate that. Please don't forget, P hat is merely X over N. So 24 over 85. Let's take a look at that real quickly. 24 divided by 85. And sure enough, we get 0.2823. And the top population proportion is 18%, which is 18 divided by 100, so 0.18. We already know we're going to be running a one proportion z-test. So there it is. All right, so that's what we're running. So then we're going to be taking a look at our drawing, and keep in mind when we're drawing one of these, we'll always need to be centered on the population proportion. Because it's a test, whenever it's a test, we're centered on P. If it's on a confidence interval, we're centered on P hat. So we already said the population proportion is 18%, and there it is centered on that. We said that 0.2823, which came from our X over our N that we had right here. And we indicated that they wanted more, and so that's a greater than. All right, so when we go ahead to plug in, our sample proportion was 0.2823, so it went right there, minus the population proportion of 18, and then we're plugging in population proportion, and right here, instead of being 970, this should be 85. All right, so let's change that to an 85. Because 970 was our population, 85 was the number of customers. Continuing on. So at this point, now that we've already done this, we can go ahead and write our null and alternative hypothesis. The null is P equals 0.18, or if you prefer, P0 equals 18%, with an alternative of P0 is greater than 18%. That should be a greater than sign. And that's because they're saying they are expecting it to be more. Please keeping in mind, this greater than, all ties back to that more over there. So normally at this point, we'd write our parameter, and then, but we're going to wait that for our um, exit ticket. But if we were to say something, we'd probably say something like, let P equal the true population proportion of customers getting soda when they paid for water at the Slurp Shack. All right, so at this point, let's go ahead and run this test. We're going to go stat test, one proportion z test. The claim was 18%, so 18 divided by 100. 24 people took soda when they said that they're getting water. We had a random sample of 85 water cups. We have the greater than that we indicated here. And we ended up getting a p-value of 0.007. So the probability that z is greater than 2.4562 equals 0.007. Well, 0.007, we're comparing it to an alpha of 0.03. Well, this is definitely less than that, so our decision would be to reject the null. All right. In the exit video, we will write the conclusions for this. All right. So if you want to see that, you'll need to watch the exit video. All right. So what's the actual true population proportion that is being taken? We're going to try to estimate that. We're going to estimate it by doing a 90% confidence interval. All right. So our formula is simply p hat plus or minus z star, etc. Okay. And we've already established where this came from. I will remind you once again that p hat equals x over n. We've had 24 people taking Coke or soda when they said that they're getting water. We had a random sample of 85 water cups taken, and 24 divided by 85 is 0.2823, which is the same information we had before. All right, so at this point, we actually have, we have p hat. And please remember, can't stress this enough, when we're working with a confidence interval, p hat for confidence interval. P is for test, p hats are for confidence interval. So here I have my p hat. It's like, oh, I got p hat, I have n, but what I don't have is z star. So in other words, I have my sample proportions. I need it here, here, and here, and I have my sample size. All right. But what I don't have is z star. So we're going to have to calculate that. And they wanted a 90% confidence interval. So we're going to go ahead and calculate that by going second vars, inverse, oops, don't know what I did, but that did look bad. So second vars, inverse norm, parenthesis 1 minus 0.90, close parenthesis, divided by 2. All right. Because we're working for a z, we're looking for a 0 and a 1, and we're always going to keep this to the left. And we'll go ahead and make this positive. So we're going to end up with a positive 1.6448. Once again, 1 minus 0.90 divided by 2, mean is 0. Standard deviation of 1 coming from the left, and that's our z. When we're drawing this thing, because we're working with a confidence interval, we're going to be centered on p hat. So we have to be centered on 0.2823, which we are. Okay? And we're going to show 90% in between. Once again, please remember this is p hat. We're not using the 90%. We're not using the claim number. So when I plug into the formula, we have P hat. Well, P hat's 0.2823, so it goes there. We have our Z star, which we calculated right above, 1.6448. And then we still have another P hat, so we copied it over. 1 minus the P hat, or 1 minus the sample proportion. Copy that down. And there is our sample size. Okay? So procedure, 1 proportion Z interval. And let's go ahead and run this thing to get that. So to run it, we're going to go stat test. We're going to drop all the way down to letter A in this case. And we have 24 and 85, and I'll change that confidence level to 90 divided by 100, so 90%. And we end up with 0.2024. So we expect, basically, based on our interval, we think that the Slurp Shop is having 20% of the customers are taking Coke to 36%. We don't know where it is. If we wanted to get that interval smaller, we probably need to increase our sample size. All right, this concludes the warm-up. In the exit ticket, we will write the conclusions for this. Appreciate you watching. Look forward to seeing you on the next one. Thank you.